Alright guys, welcome to this video, and in today's session we are beginning new C++ series, and this series is for mainly intermediate developers, people who have knowledge about C++. If you don't have knowledge about C++ and this is your first time to encounter and come into contact with C++, this might not be the right series for you or the right video. But if you think you're hard enough, you can, well, dive in. But I would advise that you check on our beginner C++ series and begin from there. So in today's session, or in today's video, we are looking at C++ templates. What are templates and why templates? Templates are very powerful entities in C++ as a language, and they give us power to make a lot of abstractions and improve our code, make it modular, and create strong APIs within our code bases. So I'll head over to my terminal. I'm already there, and in my folder I want to create a folder here called templates. Yeah, why not? So I'll go into templates and open the folder with VS Code. With code.space, it has opened. Here we are. Okay. Now, I'll create a file. I'll call it main.cpp. In this area, my assumption is you have some knowledge of C++ and you know the basic things in C++. Things like types, functions, like that. So as usual in C++, I want to include the IOStream header file. Okay, for now I'll begin with that. Now, before we go into deep coding, we need to discuss a little bit about templates. So, and specifically, today we are talking about function templates, and perhaps even in the subsequent videos we are going to be talking about function templates, and later on we will look at class templates, but for now we are looking at function templates. And we know what a function is. So function templates are functions that are parameterized. For example, instead of in places where we're supposed to have types, concrete types declared explicitly, we are having templates, sort of like placeholders, as you are going to see, that are holding these types that we should expect. So these function templates, they represent a family of functions, so to say, and they introduce a behavior in our code that can be called for different types. So we can write a function, and the function arguments can be changed from integers to strings, to doubles, to floats, to anything, using that same function, sort of overloading it in a way. But we'll look at overloading function templates also. So templates just about representing types. In brief, they are just about that. So they are sort of ordinary functions, but the difference is some elements within that function are left undetermined. Okay, how do we use or how do we write function templates in C++? Here we go. So we have this keyword type name, sorry, not type name, template, and we use these brackets. We are going to talk about them, but for now we open it as the less sign, and text type name is a keyword that we use, and we declare the type with any variable, but conventionally we will stick to T. So template type T. And now we want to write the function. So our function is not void, therefore we need a return type, the type that is supposed to be returned. And with our type we want to return is the T itself, or the template type that we want to return. So T max. We want to write a max function that checks between two variables or between two arguments which one is greater. So t of a and t of b. So this function takes two arguments or two parameters, and we want to check which one is greater. We want to return. We are using this short form of writing the if statement or conditional checking within C++, and this is some sort of, it's a syntactic sugar, so to say. So basically what we are saying is that if b is less than a, okay, if b is less than a, return, what do you want? Return a, because a is bigger and you want the maximum. Otherwise, return b. As simple as that. What we want from here is we have declared our function iostream, and the next thing that we might need is the main function to check out really what's happening here. Return 0. At this level, I assume you have some knowledge of C++. Like I said, there are things I might not be able to explain. I don't know why we have this error here, but a quick fix is compiler path setting. Compiler path, you might get these errors. I don't see compiler path. Okay, it's here. Compiler path telling me to edit compiler path, which is here. Let me see if I can change it to G++, if it will take away that error. Voila. Yes, it goes. So I think we have the function, template function, takes two arguments of type templates, A and B, and we are just checking. This is some sort of a syntactic. What we are writing here is an if statement. If A is less than B, return B, yes, if A is less than B, else return A. Basically, this is what we are writing, but it's better that we, this looks nice, short, and more readable. So we need to test this, and we can first test it with some values. For example, in our main function, if we declare some integer variable result, and we want result to equal to max, where max, why don't we even just declare the integers themselves? So int a will equal to 5, and int b will equal to 6 maybe. So we want to see stdc out. So I want to print the maximum value, and I call the max function pass a and pass b, and std_endl. I want to end. So if we open our terminal here and call G++, I have the main function here. When I run, it runs there. I generate a binary file, the a.out, and I run the a.out. There are various ways of compiling a C+ file. Feel free. So as we expected, 6 is the maximum between the two. What if we want to test on strings? For example, we can test on std string 1 can equal to mathematics, and string 2 can equal to math. Using this, the maximum value between S1 and S2, which one is is greater. So we are landing into problems, and here more than one instance of the function template max matches the argument list. I want to suspect the function t std string. You know that from the standard library we have the max as a function within the standard template library. So my suspicion here is we are convoluting those two, like the two are clashing. The namespaces are clashing, and to put this in the global namespace, I'll put the scope resolution operator there and see if that works. It looks like it is working for now. The name is getting out of, but we know that from, I think, the algorithm template, standard template class, we have the max, the std max from that namespace. That's why I always want to use std max, because this helps me to see the functions that are coming from the standard template library, as you can see there. So running again, okay, we're seeing that mathematics is the max between S1 and S2. And we know that there are things that we need to look at. We've talked about this scope. This scope is important because we have, in the standard template library, we have the max function. So we needed to put the scope resolution operator or the two double dots before max, such that we avoid convoluting with that native method within the standard template library. We need to note some things, that each call of the template is qualified with the scope resolution operator, and this is just for avoiding convolution within the global namespaces. But also another thing, we need to look at the compilation of these templates. When we define this template function, we substitute here for the values and we evaluate whatever we have passed, and we get the return type. But we need to note, templates aren't compiled into single entities that can handle any type. What does that mean? Like, we do not compile our function such that there is a single entity that can handle every type. Or what is compiled to, or what the function is compiled to, is there are some type checks that happen first, and depending on what the arguments are, this function is first evaluated to the actual concrete types. So that means the concrete types get substituted. In other words, you have something like int max of int a of int b, and that means whatever you've passed your arguments, they are actual integers, like in this case. If there are strings in this case, that means we will have a return type of string, std string, happening here also. What am I pressing even? Huh? What am I typing? Oh, okay. So we need to take care of this too. So the function template, or this function, will be evaluated first to the actual concrete types of the arguments that are in. So the different entities are generated from the template for every type. That's what we need to know. So that means our max function is compiled for each of these template types that we pass through. And in some way or another, this function semantically calls this underneath if the arguments passed are strings. If they are integers, they are also substituted. Okay. And one of the things we need to note is the process of substituting for these types, or for these concrete types, by the template type, is what we call instantiation. And that means instantiation happens whenever there is type substitution, where we are substituting the templates with concrete types. And basically the instantiation is triggered by the process of substituting for those concrete types. Yeah, and that's what basically happens. And it sort of means that the template types or the template functions are compiled in sort of two phases. And that brings me to the concept of two-phase translation, whereby we have a template being substituted. So the template types are compiled. First of all, the instantiation process takes place, where the template code itself is checked for correctness, and whereby we check the correctness of that code, and then the template parameters are also checked. So there are also other things that happen. Syntax errors are also checked, like the compiler is checking these things. Are you using the correct names? So then at that instantiation time, even the template code is checked again to ensure that all code is valid. And basically that's what we call the two-phase translation. And we will look at it more in other subsequent videos. So thank you very much, guys, for watching. I'll end here today in this video. Don't forget to subscribe, leave a like, and leave a comment. Bye-bye.